Hello, my name is Alexander El-Hajj. I'm an analyst with Statistics Canada, currently working on the Longitudinal and International Study of Adults, also known as LISA. This is Statistics Canada's Household Longitudinal Survey. I'm excited to be here virtually for the International PIAAC Research Conference 2022. I'll be presenting my findings on the trends in skills use and employment income over time. Let's get started. So in this presentation, you will gain a basic understanding of LISA, where we will cover the population and sample design. We will highlight the vast analytical capabilities of LISA and how the linkages to various administrative databases enhances the ability to research and detail various policies. We'll go over some limitations of LISA as well as with the PIAAC data. And finally, we'll explore the trends between skills use and employment income over a 4-wave period. So LISA is a longitudinal study that examines changes in Canadian society over time. The target population is Canadians of all ages in 2012 living in the 10 provinces, plus their future descendants. In wave 1, we had 2 subpopulations. The first, considered the LISA sample, was Canadians 15 years of age and older in 2012 living in the 10 provinces. The second subpopulation, considered the PIAAC sample, was Canadians 16 to 64 years of age in 2012 living in the 10 provinces. Combined, these two subpopulations form the basis of the LISA and PIAAC longitudinal sample, respectively. The initial sample as of wave 1 was approximately 34,000 individuals and more than 11,000 households. Some of the content includes labor, education, health, families. We also add themed content as well. Collection for LISA is every 2 years. Currently, 4 waves are published, wave 1 to wave 4. Where wave 1 was integrated with PIAAC. The PIAAC design strategy was to collect PIAAC data on those respondents in wave 1 and follow them longitudinally along with the other respondents throughout each wave. LISA also links to 4 administrative databases where each one contributes to the survey in a unique way without having to extend the interview. The benefits of these linkages are fourfold. It reduces response burden, reduces collection costs, improves data quality, and for research and public policy. Admin data was linked when respondents gave permission via questionnaire. In this study, we use the T4 tax slip database. If you're a salaried employee, essentially you must fill this out. Is essentially a summary of the employment earnings and deductions for this year. The years available for this tax slip are from 2000 to 2019. In this study, we use the employment income variable as the indicator to assess the change in employment income over time. We'll talk more about this in the methodology. The other 3 admin databases linked to LISA include topics such as immigration, pension, and income estimates for the individuals and families. You can see them over here. On the right-hand side, you can see a hierarchical graph, and that shows the databases used in LISA. So in wave 1, we have the overall LISA survey was combined with the LISA data, the PIAAC data, and the 4 administrative databases. And for each subsequent wave, there's LISA data along with the corresponding admin data. To note, the admin data is every year, while LISA data is every 2 years. So there's some strategies that you can use to actually perform analysis with these databases. The admin data enhances and extends the analytical capabilities, as this data is usually more accurate than survey data as well as more comprehensive. Now let's get into the paper. Let's get into how the analysis was, the layout of the analysis conducted in this paper. On the right-hand side, you'll see kind of the format of it. So we first have the derived variables. We have a derived version of the skills use indices, a derived version of the PIAAC numeracy and literacy scores, as well as employment income in 2018 dollars, all from wave 1. And then we track the employment income growth over the next 3 waves. So in total, we examine the change in employment income over a 4-wave period among those who use skills more or less frequently in wave 1. So the research question here is we're looking at which skills, when used more or less frequently, result in the most growth in employment income over a 4-wave period. And just to note that these are descriptive statistics and do not account for confounding factors, as would be included if a multivariate analysis was conducted. We also assess differences in employment income growth among those who achieved high or low scores in the literacy and numeracy proficiency levels in wave 1. So When we describe the skills use data, we're actually using the skills data from the survey of adult skills from PIAAC. And in the PIAAC survey, there's 3 variables: mean, standard error of the mean, and skills use indices. Though in the LISA survey, we only include the mean and the categorized skill variable. So for the skill indices, a high value means the individual uses that skill frequently, and a low value means the individual uses that skill less frequently, rarely. The skill use indices can be negative due to standardization, and are also continuous. These are the list of the 13 skills use indices we use to assess the change in employment income over time. There's 9 skills use indices that are for the skills used at work, and 4 for the skills used in everyday life or outside of work. Now for the methodology. Now let's understand the sample that I use for the study. Now the beginning sample I start off with is the longitudinal sample. Now that's a number of people that are longitudinal respondents from wave 1 to wave 4. So longitudinal respondents are those who have been respondents for every past and current wave. So from wave 1, they're 15 and older and responded. Wave 2, they responded. Wave 3, we responded, and wave 4 responded. They must be respondents in all those 4 waves to be considered a longitudinal respondent. Now those people who have responded from wave 1 to wave 4 consecutively, total is 10,640. Now we take the subset of that, which is the longitudinal PIAAC sample, and those are the longitudinal respondents that have also completed the PIAAC questionnaire. Now the final sample of 2,554 is the PIAAC sample who have employment income data for all waves. Now let's go back to the green shape over here. Just to recall, the study sample is the longitudinal PIAAC respondents with employment income in all waves. Now, the skills use indices are derived into binary variables, where 1 means the skill is used frequently and 2 means it's used less frequently. And the same thing is done for the literacy and numeracy proficiency levels, where if the variable is 1, it means you had a high proficiency in literacy or numeracy, and then 2 if you scored a low to moderate proficiency. Now, literacy and numeracy are 2 separate variables, just to make that clear. Now let's figure out how we calculated employment income. Let's go over here. Now, in order to use employment income, we had to conduct some calculations with it before we can actually use it for analysis. Now, first, we converted employment income to constant dollars, which it was current before, and this was done to account for purchasing power. Then, since some individuals have more than one tax slip, since they have more than one employer, we summed those up to get total employment income for that year. Then we averaged the total employment income for the 2 tax years associated with each wave. Since each wave is 2 years, we average out those 2 tax years, and then you get the average employment income for wave 1. A respondent must have average employment income greater than 0 in all waves to be included in this sample. This is to ensure that we are computing estimates for those who are consistently employed. Now let's look at some key findings. Now, this line chart shows the change in employment income among those who use skills at work more frequently. Now, the y-axis shows the average employment income, and the x-axis is a time series of LISA waves from wave 1 to wave 4. And you can see the percent gain from wave 1 to wave 4, or the percent gain in employment income from wave 1 to wave 4 in the legends here. You can see that. So the next 3 slides will also be very similar in format. Essentially here we're showing the change in employment income over the 4 waves by each skill within the frequently used category. Now those who use task discretion skills frequently at work saw the largest growth in employment income over the 4-wave period with a gain of 18.1%, and you can see it in the legend right there, 18.1. And second place was readiness to learn skills with 17.8%. Now, we observe an interesting clustering behavior here. As you can see, there's 3 clusters forming, and where the top and the bottom show a moderate growth, whereas the middle cluster shows a more stagnant growth over here. And we can see from wave 1 to wave 4, task discretion, ICT, reading, and numeracy skills earned over $85,000 by the time they reached wave 4. So you see quite a big overall earnings for people who use those skills a lot at work. Now let's look at people who used skills less frequently at work. And among these people, we see that those who use influencing skills less at work had a large growth of 19.8% over the 4 waves. And here we saw planning skills. Those who use planning skills, second place with 18.5. Interestingly, those who used planning skills at work less often actually surpassed the earnings of those who used ICT skills, task discretion, and readiness to learn skills less frequently. So those three skills had less earning, those three skills had more earnings as of wave 1, but then planning skills surpassed them at wave 4. Now let's look at employment income over time among those who used skills in everyday life frequently. Now, here right away, we can tell that those who used skills in everyday life more frequently saw much larger increase in earnings compared to what we've seen in the past, like 24, 27, 32% is much higher than we've seen in the past, which is an interesting finding. And numeracy skills actually had the highest growth with about 32% gain from wave 1 to wave 4. Now, those who use skills in everyday life less often, here we see that clearly there is not much growth overall in earnings. 11%, 12% is fairly moderate. Writing skills and ICT skills follow a similar trend, whereas numeracy and reading kind of stagnate out after the second wave. Interestingly here, there's over 4 times the amount of growth in employment income when numeracy skills were used outside of work frequently compared to when they were used less frequently, respectively. So here we can see it's 7.7, and then when numeracy skills were used in everyday life frequently, it was 32, and that's over 4 times growth. Now let's look at employment income over time by derived literacy and numeracy proficiency levels. And this is pretty consistent with, I know a lot of you probably know the literature on these literacy and numeracy scores, and you can see common with most of the literature where people who tend to have higher proficiency are generally higher earners. Yellow line is those who scored high in the numeracy tests, and the orange is those who scored high in the literacy test. And we can see that those who scored high in the numeracy test not only earned more throughout all 4 ways, but also had the largest gain in income with 19.5%. And you can clearly see the difference in income between the high and low to moderate scoring individuals. There's a big gap there, and it maintains that gap throughout the remaining waves. Now let's take a look at the key findings. So task discretion skills used frequently at work saw the highest growth in employment income over that 4-wave period. Those who use task discretion skills, ICT skills, reading skills, numeracy skills frequently at work earned more on average in wave 4. Remember, at the end, they all averaged over $85,000, which was much more than we've seen in any other of the skills use categories. Those who use skills outside of work more frequently saw the largest growth in employment income. Just to recall that those who use numeracy skills saw an over 30% increase in their employment income. And finally, those who achieved high scores in the numeracy test earned more initially and gained the most in earnings over the 4-wave period. Let's quickly just have a little discussion and key takeaways from this presentation. So first, we explored some of the analytical capabilities of LISA and learned that along with survey data and PIAAC data, LISA is also linked to 4 administrative databases that cover a wide array of topics from immigration to tax data. In order to further understand why some skills more or less frequently result in a change in employment income over time, we could use the longitudinal nature of LISA to examine the socioeconomic traits such as age, education level, or occupation of those individuals. This might provide more insight into why some skills were used. They saw a larger or smaller change in employment income. For wave 1 only, since we don't have longitudinal data for these skills indices, we could conduct a multivariate analysis and explore the correlation between the different skills used. This probably could help explain why we saw the clustering in the first chart. There was, if you recall, there was the 3 different clusters. It's possible maybe those who use ICT skills a lot at work probably use numeracy skills a lot at work. So there's probably a little bit of correlation there that we can dig deeper into. And consistent with some of the current literature on the relationship between skills and income, our findings also show that those who scored higher in the literacy and numeracy test earned more overall and saw moderate growth in employment income over the 4-wave period. And this probably explains why we saw that large gap in employment income between high and low scoring individuals. These are just some references and some more information on LISA. Thank you, everyone, for listening to my presentation. I will now be taking questions.